quite often when your data is a continuous variable like ratio or interval scale, and you need to create meaningful categories out of that variable for comparison purposes, you can transform that variable into a new categorical variable by putting the values of that variable into distinct categories. This data transformation process is known as recoding. For the purpose of this exercise, I have a data file which contains the top 70 countries based on their total medal counts in the Paris 2024 Olympic Games. The data file was compiled by my students who want to study the factors affecting countries' Olympic performance. Among the many variables they compiled, one of the variables they collected is the Human Development Index, which measures a country's human development. The value of this index varies from 0 and 1, with a high score indicating a high level of human development. So as you see this data file, and this data file has 70 countries, the top 70. And I'm looking at the Human Development Index here. So there is so many ways we can divide into categories. So I'm going to show you a way to divide your data into meaningful categories. So what I want to do first is I will go to analyze and run frequencies. So on the descriptive statistics, there's a frequency, and you select the variable we are interested in. So here's a variable called United Nations Human Development Index. And I select this variable and I run the frequency. So you see this is a frequency of the Human Development Index, and I'm looking to find 1/3 of the data for the first category. So which is around 32.9% is about 1/3. So the cutoff value will be 0.785. So any number below 0.785 and 785 would be the first category. And next number I'm looking here is the next 1/3. So next 1/3 would be 66%. So closest number is 65.9, which is close to 66% is 0.908. And anything after 0.908 would be the third categories. So in order to recode your variable, you go to the transformation menu. It's a data transformation menu. There are two options. One is a recode into same variable and other is recode into different variables. So I want to create a new variable. I do not want to change the existing variables. So recording to same variables is not a good idea, because if you record the same variable, then you might lose the original variable. So I think it's a good advice to record into different variable. This is what I'm going to do. So a different variable, and you select the variable you want to record. In our example, it's a Human Development Index. I'm going to give the name. Let's call it HDI. And because it's a recode, let's call it recode. Recode, and we can label them Human Development Index. And we make a change. So it's going to create a new variable. And before we check the variable, we have to make sure that we reassign our values. So we have identified our 3 cutoff points. So the first cutoff point we identified was 0.785. So any value 0.785 or less will be our lowest categories. So we're going to call it 1. So this is the lowest through 0.785 is category number 1. And then we identify second category, which was any number above 0.785 would be 0.786 through 0.908. So we give them value 2, our second category. And the third one, any number above 7 0.908. So that would be point will be 0.909, and we give them a 3. Okay. Yeah, so we don't have any missing values. So we don't know, I mean, if there was a other values, we could say all other values as a system missing, for example, or depending upon the context or copy old values. So we don't have any old values, but if you think there are some missing values in your set, you can simply say else system missing, so it will treat as a missing value. Okay, so we don't really need to have that option because in our data set we have value for every single case, in this case the country. So we have now 3 categories. Now we say continue. There are 2 options. You can simply say okay, it will create the variable for you, or you can simply paste the syntax, the program of the log file. It will shows up on the syntax window, and we can run that syntax window. Especially it's very useful to share your syntax with your colleagues or other team members who are working on your project. But I'm going to simply say okay, and you notice that in the very last variable is the one we just created. Okay, so we can check this variable out. And this variable is shown up as nominal. We can assign as ordinal because obviously this variable 1, 2, 3 has an order. Obviously, um, code number 1 is the lowest category, code number 3 is the highest category. So it does have degree of hierarchy from small to high. Because it's a ordinal variable, categorical variable, you really don't need a decimal value. So we leave them decimal value as it is. What we should do right now is we should give them labels. Okay, so if you go to the values and you add values, so we already know that the what first was. So again assigning label, you have to exactly know the code you assign, what label you want to give. So for the purpose of this exercise, let's call our code, because this is the lowest HDI group, so let's call them a lowest H human development index at second group, and this is our intermediate HDI, and the last group is 3, which is highest HDI, or uh, high HDI. So let's call it the highest HDI. So this is our so we give the label. So we simply say okay, and if you look at the variable view, you can see the variable we just recoded them. We already assigned the code, the label, so we can toggle between the value and the text. So you can see this is a new variable we just assigned. Obviously, the next step you want to do is to run frequency of your new variable, and maybe you can run some analysis. So I'm just going to quickly run a frequency. You go on analyze, run descriptive statistics, run frequency. Select the new variable you just created and say okay. With the labels lowest HDI, intermediate HDI, highest HDI. So you can see these are the distribution, pretty fairly evenly distributed of these 3 groups. And because this project is about the importance of HDI on the countries winning a medal, so we can run a simple mean table. So there is a option called custom table. You can run a quick run of this custom table just to see uh, how the medal divided by these 3 categories. So I'll select the new variable HDI on my column and the total metal bond on a row, and we simply run this table, and you can see that country with the lowest HDI on an average won 5 medal, and the intermediate HDI has average 11 medals, whereas the high HDI has 27 medals. So we definitely see that as the HDI goes up, the then the medal counts also goes up as well. So definitely see there is a definitely has a impact HDI impact on the Olympic medals uh, winning. Uh, 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 we can do a few more things. For example, we can run a graph. If you obviously statistics without graph is not complete. We need to have a nice graphic. So if we select this bar graph, and we can put the total number of medal on a y-axis, and on the x-axis is our human development index. If you say okay, and you have this chart, you can see that you can have this chart. Of course, if you double click on the chart, you can ask for the labels. It will give you labels, for example, and you have this chart. Now, we cannot say statistically if the difference is significant. To see if the this means a statistically significant among this group, we can run a ANOVA. So there is a one-way ANOVA test, which is a great test to run if the mean among groups are same or different. So the test is called one-way ANOVA, and you select your total number of medals as a dependent variable, and the human development index numerically created as a factor. There are a few options. The Tukey test to measure the peer differences, if there is any. There's option you can look for a homogeneity variance test. I mean, we already have this bar chart, but we can also ask for mean plot if you just want to have a quick look at the mean chart. There's descriptive statistics as well. And they simply say, okay, so this is your one-way ANOVA output. This is the averages of each of those categories within our new HDI recode variable, which is very similar to what we just saw. We just ran the custom tables, and this is a living test, yeah, homogeneity variance test. And this is a main output on one-way ANOVA output, and you can see that the significance value, which is also known as p-value, is 0.001, which is way less than 5%. That means that the our test is significant, which means that reject our null hypothesis saying that all groups are same statistically, but now we can say that all groups are not same. Now, this is a Tukey test, um, which really compares the peer differences. So we can definitely see that, for example, the highest HDI group has a significant different from both, actually, both the lowest and intermediate groups. Okay, so country with the highest HDI, their medal count is significantly higher than lowest and intermediate. Whereas if you compare the lowest and intermediate, and statistically there's no difference between lowest and the intermediate group. So that is your one-way ANOVA, and yeah, this is the same chart. So nice line chart. You can see that as the HDI goes up, the average medal of counts goes up as well. I also want to show you how to run a two-way ANOVA in SPSS. To run a two-way ANOVA, you need two factors, and we can use our recode variable HDI. And this data file also have another variable, which is a continent. So we can run a two-way ANOVA using these two variables. So to do a two-way ANOVA, we go on analyze, and in general linear model, there is a option called univariate. In the univariate, we first select our dependent variable, which is a total number of medals won. And you see this is a numerical variable. And in this data file, you already know that we have created this variable called human development index recode. And then this data file also contains this variable, which is called continent. So we're going to select the continent as another factor. And we can do a plot. We can use the HDI recode as a horizontal line and the continent as a separate line, and we can add them for the plot. So this will give us an interaction plot, and we'll continue. And on the post hoc, it will give us the results of the Tukey test, the pair comparison, if there's a difference exist between the pairs of the groups. And in the option, there are a few things we can ask for. One is a homogeneity test, and one is a descriptive statistics. And we continue, and we say, okay, so this is your two-way ANOVA results. So there is a descriptive statistics, which it shows you how different human development index, how these countries performed, for example. So you can see that in the lowest HDI, these are the average means of metal bond. So seems to be not a huge difference. And the intermediate HDI, you definitely see that Asia has a relatively more metal compared to Americas and Oceania and Europe. And in the highest, which is very interesting, so in highest, everybody has a more metal compared to the lowest intermediate, but you can see that Americas and Oceania countries' metal counts has significantly gone up. All right, so this is interesting pattern. You notice that, and um, and and this is a two-way ANOVA result, and you see that in the HDR Recode, which is significant, which we already knew from our one-way ANOVA. What is interesting thing is that there seems to be interaction happening between Recode and continent. It's a p-value is 0.051. It's very close to 0.05. And remember, the sample size is really 70. So if sample size was uh, slightly more, this number will be probably less than 0.05. Okay, so we can definitely see there is a significance, and yeah, so this is a multiple comparison. You can see this the for the human development index, which we already knew earlier. The highest HDI has a significant difference from lowest and intermediate groups. And with respect to the continent, it doesn't seem the continent itself is significantly different. So there's no effect due to the continents on the metal counts, 0.448, the p-value. And yeah, so this is a very interesting plot. This plot is called interaction plot. And you can see what we observed in our descriptive statistics. We can definitely see that is the for the Americas, Oceania countries, as soon as the it comes to the highest HDI level, the the average metal count's gone up significantly high. So you can see that. So this is your two-way ANOVA, and yeah, have fun doing this analysis and try to recode your variable for your project. Good luck, everyone.